hardware profile and real mode driver loading phases. So the initial phases of Windows 98 startup occur in real mode. So that makes sense, right? Because we're not going to virtualize. We got to load all that virtualization stuff. So everything starts in real mode. We load that very first set of memory. We talked about that. Then it starts from the memory and works its way down. The Windows 98 or the high memory and works its way down in the memory addressing. So the Windows 98 IOSys file loads first and then loads many core settings. The IOSys loads MS-DOS-sys, which prepares or processes the config-sys and the AutoExec-BAT files if they are present. If real mode drivers are loaded within config-sys and AutoExec-BAT, Windows 98 performance can degrade because all that stuff has already been loaded already. So considerations for using config-sys and AutoExec-BAT. Do not include mouse support in either file. Do not include smart drive sys commands in the config-sys. IOSys now handles many older AutoExec-BAT settings. Do not reference other versions of Microsoft Windows that are present on the drive. So if you've done an upgrade, don't try to load something from the older version. Ensure that the Windows and Windows command directories are in the path statements. So if you're going to modify your path, don't overwrite those. Use the system or device driver or registry in Windows 98 for device and memory settings. Protected mode initialization phase. So the protected mode initialization phase. Startup invokes win.com. The boot process loads a series of static and dynamic VXDs, including VMM, Virtual Memory Manager 32.vxd, and the system INI file is then processed. The configuration manager then loads additional drivers as needed. So you're gonna need to understand this boot process. Okay, so there will be several questions about this, but it kind of makes sense if you just kind of pay attention. So you may need to review this section a little bit. So the kernel 32 DLL, the kernel 386 GDI, the graphics device interface, right, and then the GDI 32 and user exe and user 32 exe are loaded. So note that the only discrepancy, the 32 always comes second except for the KRNL, right? So don't mix those two. It's kernel 32 and then the kernel 386, okay? Otherwise, the 32s come second. And then the desktop is built and the logon dialog box appears. So there's alternate startup methods and resources. The Windows 98 startup menu can be accessed either manually or automatically. And also this is true of modern versions of Windows as well. We can mix and match the startup method, right? And then startup menu options may vary, but common ones are normal, logged, safe mode, step-by-step confirmation, command prompt only, and safe mode command prompt only. Okay, those are our options. Those ones in the slide should not be there. This is just only. So the startup disk can be used to boot Windows 98 and access startup menu. So a startup disk can be used to boot Windows 98 and access the startup menu. So you can tell it what you want to load. The win.com command. Windows 98 can be started manually by invoking the win.com with one of the following switches. The -D, as in Delta, starts Windows 98 in safe mode with another option. The -F, as in Frank, disables 32-bit access. The -M, as in Mike, starts Windows 98 in safe mode. The -S, as in Sam, limits the Windows memory 98, limits the memory Windows 98 can use. So S limits the memory, S as in Sam, limits the memory Windows 98 can use. The -V, as in Victor, handles interrupts from the hard disk controller. And the -X, as in X-ray, excludes all of the adapters or adapter area from the range of memory scanned. So the -X, as in X-ray, excludes all of the adapter area from the range of memory scanned. The bootlog.txt can be generated by using the logged option from the startup menu. Logs each action during the boot process and whether it succeeded or failed. It is a powerful troubleshooting tool. The Windows 2000 system design advanced features. So the ability to run both complex and instruction set computing, so CISC, complex instruction set, and reduced instruction set computing processors. So it can run CISC and RISC processors. What's the difference? So complex instruction set computing and reduced instruction set computing. So we're talking about instruction sets, and the difference is that RISC processors run X amount of instructions per second. So we have MIPS processors, which is 1,000,000 instructions per second. Those are Motorola processors. And those will run 1,000,000 instructions per second. So I can figure out exactly how long it's going to take my program to run because I'm running 1,000,000 of instructions per second. So the Motorola MIPS processors are what used to run on like the old Mac computers. Those were running on Motorola chips, and they used RISC instruction sets. So now the Windows used to run on CISC only, so we had the complex instruction set. So with the RISC, if I had one instruction, it's going to take one or X amount of CPU ticks to run it. So every instruction took X amount of CPU ticks to run. With complex instruction set, you don't know how many CPU ticks it's going to take to complete that instruction on any given instruction. So depending on what parameters are passed and stuff like that, how the instructions, whatever, some instructions are going to take X amount every time, but based on the parameters, some can vary, right? So complex instruction set, that's the difference. With reduced instruction set, you know exactly how many CPU ticks they're going to take to execute. With the complex instruction set, you do not. So they have pipelining, they have bursting, they have all different kinds of things in the complex instruction set. So there's a huge architectural difference between CISC and RISC.